Welcome to the System Clock course of the HT8 MCU Basic Tutorial. This course will take you through the system clock of the HT8 MCU from the following 5 aspects. System clock introduction, instruction cycle and pipelining, clock frequency, system clock structure, and system clock configuration. System clock introduction. What is clock? The clock is the pulse of the MCU. The program running and the use of any peripherals all rely on the clock. Simply speaking, a clock is a series of square waves with a fixed frequency, which are pulsating signals that change periodically. The MCU operation is controlled basing on the time period between each rising edge and falling edge of the clock. According to this clock square wave, a consecutive high and low level is called one clock cycle. Instruction cycle and pipelining. For the HT8 MCUs, 4 clock cycles form a single instruction cycle. The execution of each code requires at least one instruction cycle. Each instruction is divided into 4 phase clocks, which are phase clock T1, phase clocked T2, phase clocked T3 and phase clock T4, and each phase clock performs a different action. In phase clock T1, the program counter automatically increases by 1 and fetches an instruction. In phase clock T2 to T4, the MCU decodes and executes the instruction. Note that the program counter points to the address of the next instruction to be executed, and will automatically increase by 1 after each instruction execution. To speed up the program running, the HT8 MCUs adopt a special pipelining method, which operates in units of instruction cycle. During the instruction decoding and execution, the program counter increases by 1 to fetch the next instruction, and so on. In this way, 2 instructions can be processed simultaneously, saving a lot of time. How is the program code executed in an MCU? Each code section is divided into multiple instructions, and each instruction performs different actions in different phase clocks. When all instructions has been executed, the code section is considered to be completed. Clock frequency. We also need to learn one more thing, that is clock frequency. It is measured in hertz, indicating how many clock cycles per second. For example, 8 MHz means that there are 8 million clock cycles in 1 second. The clock frequency directly determines the speed at which the program runs. For example, if there are 4 clock cycles in a certain time period for the 8 MHz clock frequency, then there are 8 clock cycles in the same time period for the 16 MHz clock frequency. More clock cycles means more instruction cycles to execute instructions, and the program runs faster. System clock structure. The system clock structure of the MCU is generally divided into 4 parts. Part 1, clock source, which is used to generate clock signals, and generally there are multiple clock sources. Part 2, clock source select, which is used to select the desired clock source. Part 3, clock frequency select, which is used to select the desired clock frequency. Part 4 is to generate the final clock signal. So, how can we select the clock source and clock frequency? By configuring the relevant registers. Registers can be used to store and process data, check status, and configure functions. More details will be introduced in the subsequent courses. There are 5 clock sources in HT8 MCUs, which are internal high-speed RC oscillator, internal medium-speed RC oscillator, external high-speed crystal oscillator, external low-speed crystal oscillator, and internal low-speed RC oscillator. These are categorized as high-speed oscillators and low-speed oscillators. High-speed oscillators generate high-frequency clock signals. Configure the relevant register to select the desired high-frequency clock source, which is used as the system clock directly or divided by n through a prescaler then provided to the system clock. Low-speed oscillators generate low-frequency clock signals. Configure the relevant register to select the desired low-frequency clock source, which is output directly or provided to the system clock. The frequency of the system clock, from either a high frequency or a low frequency source, is selected using the CKS2 to CKS0 bits in the SCC register. The system clock, low frequency clock source, and the internal low speed RC oscillator output clock signal can be provided to other peripherals for use. It should be noted that the clocks are active in normal operation, but some clocks will be turned off or switched to other sources when in the idle or sleep mode. This will be introduced in the subsequent course. System clock configuration. As shown in the system clock structure, the system clock configuration is mainly to configure the oscillator and prescaler relevant registers. Let's take the HT66F3195 as an example to configure its internal high-speed RC oscillator to generate a 4 MHz system clock frequency. First, this MCU defaults to use the internal high-speed RC oscillator with a frequency of 8 MHz, so the oscillator selection has completed. Then configure the prescaler by selecting the divided by 2 option to obtain a 4 MHz frequency. This involves the CKS2 to CKS0 bits in the system clock control register SCC, which are used to configure the system clock prescaler. Dividing the internal high-speed RC oscillator's frequency 8 MHz by 2 can obtain a 4 MHz. This means to set the CKS2 to CKS0 bits to 001. Course summary. In this course, we have learned about clock cycle, instruction cycle and pipelining, clock frequency, system clock structure, and system clock configuration. You will have a clear understanding of the system clock. Holtec has a professional service team to assist in development design and after-sales service. Please feel free to contact our business departments for more detailed product information and consultation services.